Okay, so in this section, we're going to be multiplying polynomials, and I'm sure you've seen this in the past. Okay, so here we have -7, and we're going to multiply that to 4x minus 1. So we just use the distributive property to multiply, right? So I'm going to multiply -7 to 4x, and then I'm going to multiply -7 to minus 1. So when we do that, we're going to get -28x plus 7, and that's it, right? And that would be our answer for this. Okay, next one we have two binomials. One has two terms, that's why it's called a binomial. All right, so we're going to multiply these together. I'm going to show you two ways. One is one you're familiar with or you've heard before, and that's using the FOIL method, right? So FOIL, F-O-I-L. That stands for first, outer, inner, last. First, outer, inner, last. So we're going to multiply the first terms, which will be these guys here. So that's our F. And then we're going to multiply the outer terms. That's going to be our O. And then we're going to multiply the inside terms. That's going to be our I. And then we're going to multiply our last terms. Okay? So actually, let me see here. Pause this for a second. Okay, gotta make a correction here. It should be this one. I already did that one, the outer terms. It's these guys here. Those are the last terms. I normally don't use the FOIL method. I use something else, but I'll show you that in a second. Anyway, but a lot of people are familiar with this, so I will show this one. So you have the first terms, right? So that would be z times 2z, right? Z times 2z. Then you have your outer terms, which is going to be z times -1. Then you have your inside terms, which is going to be 6 times 2z. And then you have your last terms, which is going to be 6 times -1. So when you do this, you'll get what? 2z squared equals -z equals 12z equals -6. Okay? And then you just combine like terms. So this will be 2z squared minus z plus 12z minus 6. So then you combine these guys together. So that gives us 2z squared plus 11z minus 6. Okay? And then that will be our answer here. So this is method 1, which again, I'm sure you've seen in the past. Okay? I'm going to show you method 2, which basically is like method 1, but for me, it just makes a lot more sense. Okay? So my method 2 for this one, it's just for me, I don't have to worry about first, outer, inner, last. I just distribute it. So again, I have z plus 6 times 2z minus 1. So I'm just going to take the first term and then multiply the binomial. So z times 2z minus 1. All right, so I just take this one and I multiply each term. Then I do the same thing and I get the 6 and multiply it to each term. So that'll be plus 6 times 2z minus 1. For me, that's a lot easier to remember. I've always done it this way. So now I can just distribute. But again, if you want to do FOIL, you're absolutely fine. So you got 2z squared minus z plus 12z minus 6. So that gives us 2z squared plus 11z minus 6. Okay? Different method. For me, it's much faster. I just take one term, multiply the two, take one other term, multiply the other two. That's it. Okay? So we get the exact same answer. Right? I'm going to do the exact same thing for the last one. Okay? So we have, I'm going to take this one, multiply it to each term, and then I'm going to take the second term, multiply it to each term. Okay, so that gives me 5x x squared minus 3x plus 2. And then we have plus 4 times x squared minus 3x plus 2. So then I distribute, that gives me 5x to the third minus 15x squared plus 10x plus 4x squared minus 12x plus 8. Then I combine my like terms, so 5 plus 4 will give us 9x to the cube. X squares, sorry, nope, 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 I take it back. We just have a 5x to the cube. Then we can have the 15x squared and the 4x squared. So we can have this one here with this one here, okay? All right, so that will give us what? Minus 11. So that'll be minus 11x squared, minus 15 minus 4, plus 4, okay? And then we have the 10x and the minus 12x. So plus 10 minus 12 will give us minus 2x. And then we have a plus 8. And then there's our answer there.